Planting a tree, it feels so simple, right? A pure, straightforward way to fight climate change. A tree goes into the ground, carbon comes out of the sky. But what if I told you that simple act is at the heart of a multi-billion-dollar market? A market where just feeling good about it isn't nearly enough. In that world, you absolutely need proof.
And that right there, that is the multi-billion-dollar question. How do you actually prove that a new forest is pulling carbon out of the air? How can a company that's buying a carbon credit be sure, like 100% sure, that their money is making a real difference? Because let's be honest, without a credible answer, the whole voluntary carbon market starts to look pretty shaky.
Well, that's where this thing comes in. VM0047. It might just look like a code name, but it is the official, globally recognized rulebook for solving exactly this problem. It lays out in incredible detail how to make sure these projects are trustworthy, measurable, and are genuinely changing things for the better. Honestly, you can think of it as the constitution for counting carbon in new forests.
Now, what's so smart about this rulebook is that it recognizes that not all tree planting projects are the same. It's not a one-size-fits-all deal. Instead, it gives project developers two very distinct playbooks to follow. One is for creating huge, new forests on empty land. And the other? Well, that's for something totally different, carefully weaving trees into landscapes that people are already using.
This slide really breaks down those two paths, and the best way to get your head around the difference is with this analogy. The area-based approach? That's kind of like taking a forest poll. You scientifically sample a large area to get a clear picture. The census-based approach, on the other hand, is exactly what it sounds like. A tree census where every single tree gets counted. Two very different methods for two very different types of projects.
Okay, so let's dive into that first one, the area-based approach. This is the playbook for those massive, really ambitious reforestation projects. We're talking about the kind that aim to turn huge stretches of land back into the dense, thriving forests they might have been a long time ago.
The process here is really logical and scientific. First, you map out the entire boundary of the project. Now, since you can't measure every single tree in a giant forest, you set up these smaller, representative sample plots to measure the carbon. Then, and this is the absolute key, you compare what you find in those plots to control plots that are outside the project. From there, you can reliably scale up your findings and estimate the carbon captured across the whole forest.
And that brings us to maybe the most important piece of this whole puzzle, the control plot. It's not just any old piece of land. It's a very carefully selected area that's almost identical to the project land, but it's left completely alone. It acts as the scientific baseline. It answers that critical question, what would have happened here anyway if we did nothing? This is what proves the project's growth is truly additional and not just business as usual.
All right, let's switch gears to that second playbook, the census-based approach. This is designed for a completely different scenario. Think about integrating trees directly into a working farm, without actually stopping the farming. This is a practice you'll often hear called agroforestry. So the first rule here might surprise you. You can have a maximum of just 50 trees per hectare. And you might be thinking, wait, why so few? Well, that low density is a crucial safeguard. It guarantees that the original land use, whether it's farming or grazing animals, can continue right alongside the trees. This is so important because it prevents the project from just pushing those activities and the emissions they cause somewhere else.
Yeah, the rules for this approach are incredibly strict, as you can see. The original farming, it has to continue, no exceptions. And with trees so spread out, you can't use estimates. You have to do a full-on census. Every single tree, or what they call a planting unit, gets its own unique ID and is tracked with GPS or a tag. And because that original activity isn't displaced, the risk of leakage, which is a huge concern in carbon accounting, is considered to be zero.
So look, it doesn't matter if you're taking a forest poll or a tree census. Both paths, at the end of the day, have to answer one final massive question. Would this have happened anyway? If you take away the money from the carbon credit, would these trees still have been planted? This is what's known as the additionality test.
Additionality. This is, without a doubt, the bedrock of any credible carbon credit. It's the core principle that ensures the money is creating new climate action, not just paying for something that was going to happen anyway. The impact has to be truly above and beyond what would have happened otherwise.
And to prove this, projects have to pass a whole series of tough tests. As you can see, both approaches have to show they aren't already required by some law, and they have to prove they wouldn't make financial sense without the carbon credits. After that, the tests split. The big forest projects get measured against a performance benchmark. The smaller agroforestry projects, they have to prove that what they're doing isn't already common practice in their region.
And, this quote really nails the whole theme of this rulebook. It might feel like a dizzying amount of technical detail, but that's exactly the point. The credibility of the entire carbon market and the trust that we can place in these amazing natural climate solutions is forged in these very details.
So here's the big takeaway. These incredibly detailed rulebooks like VM047, they aren't just red tape. They are what separate a nice idea from real, verifiable, actual climate action. They provide the trust and the transparency we need to turn an investment in trees into a genuine, positive impact on our atmosphere. And all of this leads to a massive, exciting question for the future. We now have a credible, robust way to count the carbon. So the question is no longer if we can trust these projects, it's how far can we take them? With these rules in place, what is the true potential of nature to help us solve the climate crisis?